How's everybody doing out there? AP Calculus. Hey, welcome out there. This show is for you, yes you, the AP Calculus student, staying after school every Thursday. To do what? To prepare yourselves for the AP Calculus exam, which is in how many days? 54! Horace Grant, Chicago Bulls champion in the 90s, that was his number. Nobody really cares about that. But who we got calling out there? Who's out there? Michael?
Yeah, Buzz.
Michael.
Hey, Greg.
Michael, I can't hear you, Michael. Can you speak up a little bit?
I'm yelling.
Hey, let's go to this picture. Michael Lewis!
Hey, Greg.
I can hear you a little bit, Michael. Yell as loud as you can, okay?
Okay,
Hey,
I was just wondering,
try this picture. Try this right here. Try this problem.
wait, how come we're not on the beginning of the show?
Find the area bounded by the coordinate x's, line x equals 2, and the curve x equals y equals... That's right! If you want to find the area, what do you have to do, Michael?
Let me read this.
Take the integral.
Integration.
Okay, so what do we want to do?
Let me see. I don't know.
Hey.
Integrate.
Okay, so how do we want to set it up?
Integrate from 0 to 2.
Okay, from 0 to 2, great.
Of x squared, a quantity x squared plus 3, dx.
Okay, x squared. Why do we want to do that, Michael?
Because we're finding the area under the curve.
That's right, because anytime we want to find the area, it's a definite integral, right?
What's that?
Okay, so what do we do from here?
Bump it up and divide.
Bump it up and divide, baby. Bump it up and divide.
X cubed over 3 plus 3x plus, that's it. Run it from 0 to 2.
Okay, so what do you want to do from there?
Plug the 2 into the x.
Okay, so we got 8 thirds plus 6 minus 0, right?
Yeah. Minus 0.
Okay, so from there, so the then final answer is going to be what?
I can't see.
You can't see?
Okay. What is? Seven and 2/3.
That's right. So, okay, so you got 26 over 3, right?
Yeah.
Okay, hey, that's a great job. Do we have another caller out there? I can't hear. Guillermo, from what school?
Hello?
From Brian Ames. Okay, Guillermo, try this problem.
Okay.
Find the area bounded by the coordinate x's, lines y equals 1 and x equals 2. What do we want to do, Guillermo?
Can you hear me?
What's that?
Can you hear me?
I can hear you a little bit, so talk as loud as you
I
can.
can't see the problem. Could you put it up?
We want to integrate, right?
Right.
Okay, so we want to integrate, what do we want to integrate between what and what?
Can you show me the problem? I can't see it.
There.
Okay.
What do we want to do?
Y equals 1 and x equals 2.
We want to integrate between 0 and 2? Okay,
No,
and
no.
what's that?
No, that's wrong.
That's wrong? Okay, well, what should we do then?
You should integrate. Okay, hold on. Y equals 1.
Integrate what?
From. Shouldn't you turn the x into a y?
You want to turn the x into a y?
Hold on. That's a rectangle.
Okay, it's a
calculus.
rectangle, right? So what you want to do is, you got y equals 1 and x equals 2, right?
Right.
Okay.
It's pretty easy. You wouldn't need calculus for this.
Okay, so it's just a rectangle, right?
Right.
So then the answer to this would be what?
2.
Would be what?
2.
It'd be 2, right?
Right.
Okay, how would we do it if we did want to integrate, because it is the area between the curve?
You'd integrate from 0 to 2
You integrate from 0 to 2 what?
on the x-axis.
Okay, on the x-axis, okay? So, but what would go over here?
The top curve would be
Well,
x equals y equals 1,
it'd be y equals 1, right?
Right.
Okay.
and then
And so what would you do from here? What's the integral of 1?
that'd be x.
It'd be x from 0 to 2, which is equal to 2 minus 0, which is equal to 2, right?
Right.
All right, that's good job.
All right, Mr. Flack.
Make sure you call in again. Okay, I can hear everybody now, so I feel a little better.
All right.
Okay, thanks.
later.
See you.
Hello?
Bill Massey,
Absolutely.
how's it going?
Not too bad.
Hey, I got a quick question for you. Ready?
Sure.
I feel a lot better now that I can hear.
Okay.
I couldn't hear before. Hey, you want to see Miss Harmon? I got a
Sure.
picture of Miss Harmon here. With the governor! I knew we'd be able to sneak in Miss Oliphant in there some way. She, doesn't want to be on TV, but it's a beautiful picture of her. Let's.
Well, she's already in the credits.
Who's in the
No,
credits?
I'm not.
Who's it? Miss Harmon's in the credits?
Yeah, at the opening of your show.
Oh, she's in the open. See, the
Yeah.
credits I think are after the show.
Well.
All right, so, okay, let's try this. Find the area bounded by the y-axis, the line x equals 2, the curve y equals x squared plus 3, and the line y equals 1. So what do we want to do?
Okay, first let's start graphing.
Let's start graphing, okay?
Let's see. So draw a line at x equals 2
X equals 2, okay?
and y equals 1,
Y equals 1.
and then a parabola, x squared parabola up 3.
Okay, so it's going to look like this. So we're talking about this curve right here, right?
Mm-hmm.
So we want to find this area, right?
Yes.
So what would you have to do?
Well, you're going to want to find the area between the curve and the x-axis, and then subtract the area between the line y equals 1 and the x-axis. So you're going to want to integrate x squared plus 3
Uh-huh.
between 0 and 2, and you're going to subtract the integral of integral from 0 to 2 of 1 dx.
Right, it's exactly that. You're going to take the area of this whole thing, subtract the area underneath here, and what you're going to get is just the area in between here.
Mm-hmm.
And another way you can write it is when you have definite integrals that have the same limits, you can combine what's going on there. So it's x squared plus 3 minus 1. So it's the integral from 0 to 2 of x squared plus 2. So it's x cubed over 3 plus 2x from 0 to 2.
0 and 2.
So it's 8/3 over 3 plus 6. Is that right?
Yes.
Okay. And so what you're going to get is 18/3 plus
26/3.
8/3 is 26 over 3, right? Right. Is that the right answer?
As far as I can tell.
No, you got it. It's
What am I
8/3 plus
missing?
4. I was just checking to see if you saw that.
Oh, you tricked me.
Just checking. It'll be 20 over 3. And if you notice, the first two problems, if you remember the first two problems, the first one was x squared plus 3, find the area, and the second was find the area underneath y equals 1, and this third problem was find the area between the two, so you just had to subtract the answer to the first problem minus the answer from the second problem. Isn't that
You
exciting?
got that one by me.
What's that? Hey, I'm just trying to. I got a problem for you later, so make sure you call in again. Do you see
Okay.
Miss Harmon with the governor there?
Oh, yeah.
That's right. Don't mess with her.
I know that.
All right. Hey, great job. Call in again, okay?
Hey, I will.
Ashley Carter!
No, it's not.
What's that?
Nothing.
Counter Cowboys, baby. Counter Cowboys. Hey, Ashley.
Yes.
What'd you guys do in class today?
We started on 6-1.
6-1?
Area up
Between, okay, I'm going to give you a problem then, all right?
No.
Yeah, what do you mean no?
We just started on it.
Okay, well, we're gonna do this here, okay? We're going to do this. If I say, I'm going to make something up as we go here, okay? Just you and I. No one else is watching, okay? If I say, let's take a look. We want the area between this. Let's say I want the area between this curve and this curve, and let's just call this like x equals 3, okay? I want this area in here, okay? If we'll call this curve right here y equals x squared plus 1, okay? And then we'll call this curve y equals x. Okay, you follow me so far? Now, do you agree that this area, this shaded region, is the entire area underneath x squared plus 1, which is the shaded and unshaded? And if you subtract the unshaded, you'll get the shaded. In other words, if you take this whole thing, how would you find out this whole area right here? What would you do to figure out this whole area right here?
When you add the shaded and
right,
unshaded?
but if I said I want to forget about the shaded part, I just want this whole area. If I said find this whole area, what would you do? What's another word for area?
Integrate.
Okay, you'd integrate, right? And what would you integrate between what and what?
Huh?
You would integrate between what goes here?
0 and 2.
Okay, and what would go here?
X squared plus 1.
Okay. Okay, and the reason why that would happen, okay, the reason why is because that's just the area underneath the curve, right?
Right.
Okay, now if I wanted to find this area right here, this unshaded region, how would I do that?
Now you would do the integral. When you subtract both sides,
but I just want this area, this unshaded region right here. What would I do?
Integrate x.
Okay, integrate, that's right. Integrate x from 0 to 2, right?
Yeah.
And now if I want to get this shaded region, I just take this answer minus this answer.
Right.
Because it's the whole area minus the unshaded part will give you a shaded part. And whenever you have these limits the same, you just go 0 to 2 of x squared minus 1 minus x, and then you guys know how to do it from there, right?
Right.
Isn't that easy, Ashley?
Uh-huh.
Ashley Carter Cowboys. Carter Cowboys. Is Miss Blackwell serving any drinks out there today?
No, she's gone.
She's gone? Oh, there's like a staff development, isn't there?
Uh-huh.
Okay, well, I'm glad you guys are watching.
Okay.
Okay, call in again, all right?
Okay.
Got another good problem for you.
Bye.
Bye. Is this Jean Valjean?
Yeah, hello?
Jean Valjean!
Jean.
Jean Valjean. Hey, you know, Channel 4 is... What? This is Jean, Jean, Channel 4 is coming out there like in 20 minutes to film you guys, right?
Alright.
So you call yourself Jean Valjean.
Jean Valjean.
Jean Valjean, Les Miserables.
Les Miserables.
Les Miserables.
Yeah, that's it. You got
Try
it.
to speak French with me.
Alright.
Hey, I got a good problem for you, okay? Only because you are Jean Valjean. Hey, okay, I'm not going to start this again, but Jean, can you sing a song from Les Mis?
Excuse me?
Can you sing a song from Les Mis? Never mind. You're Jean Valjean.
Alright.
Next time you call in, make sure you know all the Les Mis songs that you possibly can.
Okay.
Okay, this ain't an easy problem.
Find it. I can't hear.
Okay, you don't hey, Jean, you don't have to hear, you just have to see.
Oh, alright. Fine. You have to integrate.
You have to integrate, correct, okay? So from there...
From 0 to square root of 3.
Okay, all right.
X over 9 plus x to the 4.
Okay, big guy, now what do we do? You don't mind if I call you big guy, do you?
No.
Okay.
So now it's looks like an arctan.
How do you know that, Jean Valjean?
Because it's 3 away.
That's right. It's more the higher the degree in the denominator is at least one more than the degree.
Yep.
Yeah, it's an arctan. You cannot stop Jean Valjean. You can only hope to contain him.
So now we can let u be x to the 4th. U
Alright.
squared be x to the 4th.
So u is equal to. So what's u equal to then?
U is x squared.
U is x squared. Okay, du is equal to x.
So du is 2x.
Okay, so what does this come out to be?
So we gotta put a 2 and pull out a 1/2. So it's 1/2 integrate from 0 to square root of 3 of du over 3 squared plus u.
Plus what?
Plus u squared.
All right, and this looks like a formula we know, right? This is arctan, right?
Yep.
It's arctan, so therefore.
So now that's 1/2.
Hey, do you make it 1/3 or not? I always forget about those arcsine and arctans. Do I pull out the 1/3? Because is that for arcsine or arctan? Where you pull out the 1 over a?
Hold on, please.
You know what I'm talking about?
Hello?
Jean Valjean. Jean Valjean, what's
Yeah. So it's 1/2. I mean, arctan of u.
U over 3,
U
right?
over 3. Yeah, u
Which
over
is x
3.
squared over
X squared
3.
over 3.
Okay, but you
From
know
0
what?
to square root of 3.
You
Yep.
forgot that multiply times 1/3.
Uh-huh.
You know why? You know how I always remember that? You know, you have arctan and arcsine, and arctan, you have a 1 over a out there, and since tan has the a in it, that's how I know it's 1 over a.
Yeah. So that's 1 over 6
So,
arctan of 0 of square root of, I can see,
it's
1
of 1 minus 1/6 arctan of 0.
So arctan of 0.
What's the arctan of 1?
So that's 1. Arctan of 1 is pi over 4.
So it's pi over 4 times 6, which is pi over
So pi
24,
over 24
minus 0
So
is equal pi over 24,
pi over
right?
24.
Jean Valjean!
Yeah.
You know, I'd say don't cry for me, Argentina, but that's from the wrong play.
All right.
Okay, hey, know all the Les Mis songs as you possibly can, all right?
Okay.
You call in again. Hey, call in when Channel 4 is on.
All right, no problem.
All right.
Hello? Yeah.
Hey, Ronnie Allen.
Yeah, it's me.
Yeah, I know. How you doing?
My problem?
Yeah, that's pretty impressive. Yeah, you're right.
Okay.
Do you know,
Oh, Mr. Everett wants to ask you a question. He's got this obsession with asking you. He wants to know. He wants to know if we can find the area between sine and cosine on the integral. So from.
wait, hold on for a second. Wait, hold on. This is not staged, ladies and gentlemen. You want to find the area between sine and cosine? There you
Yeah,
go.
my teacher has this.
Do you know,
There it is.
how about that?
Yeah, he's like, yeah, that's it.
There you go. That's pretty impressive, is it?
He wants, yeah, okay. So basically what I'm doing,
Wait, hey, Ronnie,
yeah.
say hello to Jordan.
Hello.
Okay. Hey, Ronnie, go ahead.
Find the points of intersection. Find the points of intersection.
Well, how do you do that? I don't know how to do that.
Set cosine of x equal to sine of x.
Well, when is that true?
When cosine of x minus sine of x is equal to 0.
Okay, when is that true?
I don't know.
Hey, let me ask you something.
Oh yeah.
What the sine of 0 is what?
Okay, okay.
All right.
Yeah, okay, I see what. Okay, when the tangent, that's when the tangent, if you divide by cosine, it's when the tangent is equal to 1, and then
Okay, it's when the tangents equal 1.
It's at pi over 4 and
Well, let's just do the pi over 4 part, because you got the cosine here,
Yeah.
and you got the sine here, and you know they meet at pi over 4. That's the y-axis.
Yeah.
So we want this area right there, right?
Oh, okay, I see what you're doing. Okay, so you're going to integrate from 0 to pi over 4?
Which is on top?
Cosine.
Right, just the top
cosine
curve.
x minus sine x.
What's the integral of cosine x?
Sine of x plus cosine, because that sine is, the integral of sine is
Okay, so what's sine of pi over 4?
So you evaluate it, the sine at pi over 4 is, so you plug in, hello, can you hear me?
I can hear you.
Okay, so you plug in, go, the sine at pi over 4 plus the cosine at pi over, root minus, plus root 2 over 2,
Just tell me the final answer.
It's, square root of 2. But there's a 1.
That's right, because when you plug in 0, sine is 0, 0, but cosine of 0 is 1. So that's the final answer, right? Ronnie Allen, wasn't that impressive? Mr. Everett asked a question, I got it typed up.
But we were thinking of a different problem.
Oh, well, sure. Now you say that.
Which is
What different problem were you thinking of?
which was, it's like cosine, the area between sine and cosine. From pi over 4 to 5 pi over 4.
Sure, you can do that.
Yeah, that's what.
Well,
we just wanted. He just asking. I
okay.
don't know why.
Well, let's take a look at that. Okay, let's take a look. Let's show you on the calculator.
But all you're gonna really do is.
I know.
It's gonna be an integral from pi over 4 to 5 pi over 4 sine of x minus cosine of x dx.
Well, which is going to be on top?
Because the sine's going to be on top in this case, and then.
So, and I want our window to be pi over 4.
Some of that area is okay. Now, some of that area is negative, so.
Well, hold on. Let's just take a look at it. Okay. Okay, so we'll call this, we'll just go minus 1 to 1, and we'll graph it. Okay, this is the first curve, which is cosine.
Yeah, that's it.
And here's the second curve, which is sine.
Yeah, that's it.
Well, that's easy, so it's just sine minus cosine. Curve.
No, it ain't the absolute value, because you have some that's negative and some that's positive.
That's a really good question.
It's the absolute value, because so you're going to.
That's a good question. Let me show you the reason why you just have to do top curve minus bottom curve. Okay, this is going to be. It's a really good question. Let's try to do this. Take a look over here.
I'm here.
Okay, and let's say we call this. We'll call this graph right here. Actually, I'm going to make it a little bit simpler here. Sorry, here. Let's do this one instead. Let's say we got these two curves. This is y equals 1 and y equals negative 1, and this is 1 and this is 3.
What?
If we take the area between the two curves, if you just take the area between 0 and 1, between 1 and 3 of this curve right here, all you're going to get is this top area.
Yeah.
And if you take the bottom one, it's going to subtract out the negative area, so it's going to make it a positive thing. But when you have an overlap here, when you integrate, like let's say from, if this is 1 and this is 3, this part right here is going to be positive, and this part right here is going to be negative. It's going to subtract out the negative part. So all you need to do is take the area of the top curve minus the bottom curve, because what is happening is that it takes into account all the area. You see that? Okay, that's good. So all you have to do is top curve minus bottom curve.
I'll get it later, because I haven't even.
Okay?
Okay, that's fine.
All right, but that's all you have to do. It works out, and if you play around with it.
I know, yeah.
You see it now?
Yeah, I've done it. It's just,
hey, great job.
He just asked about it.
Well, now you can answer.
If you could do know if you could do it. So
You can answer him, okay? Make sure you call in again, okay, Roddy?
Yeah.
Great job.
yeah,
Jordan says hi.
Hello?
Kathleen,
Yes.
how are you?
I'm good. How are you?
What's your last name?
Gonzalez?
Ah, Kathleen Gonzalez. How you doing?
I'm doing pretty good.
I know. Are you nervous?
No, not too much.
Okay, should I ask you a really hard one?
I think we should go with the mediocre today. It's
Mediocre.
my first time.
I only have a hard one here.
All right. I
So
guess
Ms.
I'll have
Harmon
to
saying,
do-
ha, why did he ask, right? It's like, why do you even say that? Ms. Harmon, I'm going to show you with the governor again if you don't. Good. Kathleen?
Are we looking for the derivative or?
Okay, this is a derivative, e to the arctangent of natural log of x squared.
Wow. Man. First. Yeah.
Yeah.
Okay, you need to bring your arctan down.
Okay, well, the derivative of e to the u is what?
E to the u times du.
Okay, so it's e to the arctan, this is the u, it's e to the u, e to the arctan times natural log of x squared times the derivative of u, right?
Yeah.
Okay.
So you have to take the derivative of arctan again.
Okay, so what's the derivative of arctan?
Du over 1 plus u squared.
Okay, so what's the du?
The natural log of x squared.
The derivative of natural log of x squared. And what's the derivative of natural log of x squared?
2 over x.
It's right, it's 2x over x squared, which is just 2 over x, divided by 1 plus u squared, so it's 1 plus natural log of x squared, quantity squared. Right?
Yeah.
That is an ugly looking problem. You could simplify that if you want to make it look like one denominator times 2 over x times 1 plus
Yeah. X
Net-
cubed.
x squared, like that. Right?
Uh-huh.
Pretty exciting stuff, Kathleen.
Yeah, that's pretty exciting for
Don't
the
you-
first time.
Don't you think so?
Yeah.
I know, that was a pretty hard one. They had like a derivative within a derivative within a derivative.
But we managed.
We did. We did it. We persevered. Hey, great job. Make sure you call in again, okay?
Okay, thanks.
All right, thank you. Molina! Jaguar!
Does it read out, bud?
Hey, I can hear you now. I feel a whole lot better. Hey, make sure you call back. Who am I talking with?
Hello?
Who am I talking with?
Oh, I can't hear you.
You can hear me?
Not on the phone.
Well,
Oh, this is Ernest.
Ernest.
Yep.
All right, I got your picture, Ernest.
No, we don't want to see it.
Ernest,
Yes,
we don't want to see it, but the women at Skyline do.
I doubt it.
Ernest Esparza.
You can only see the south side of my face.
What's that?
You can only see the left side.
Well, that's the good side. You know? We only show the good side here.
And it's up with my fro.
What's that?
I had a fro.
You had a fro?
I needed a haircut.
That's like from the 70s, a fro.
Afro Thunder.
Hey, Ernest, you pretty excited out there?
Excuse me?
Here you go. Here's a problem.
Is it super easy?
Super easy? I wouldn't call it super easy.
Oh, okay. Let me write that down.
You don't need to write it down. You are Ernest Esparza,
That's why I need to write it down.
the man with one side and a fro.
Do I let U equal? Is that a UE?
Who is? Oh, I know. That's Erica. Is that Erica?
Yeah.
I can tell.
Sounds like a mouse. It's like,
Hi, Greg.
is that a UE?
Yeah, it's a Yui.
Will let U equal what?
I don't know. You
E
tell
to
me.
the X?
Well, okay. You want U to equal E to the X? Let's try that.
No, 1 plus E to the X.
Ah, 1 plus
Yeah.
E to the X. Okay.
All right, and then du equals e to the x, dx.
Okay.
And then you integrate from you need an 8 in front. I mean a 1/8.
8 or 1/8? Which one?
And you bring out an 8. 1/8, and then you bring out an 8.
Well, which one you want me to write? 8 or 1/8?
You bring out the 1/8.
Bring out the 1/8? Why?
Because so
Take out the 8.
Take out the 8, okay.
Yeah, so you'll have it, the dx part thing. So it'll be 1 over e to the u.
1 over e to the u?
du over e to the u. Or du over u.
It's just du over u, right? What's the
Yeah.
integral of du over u, Eric Sparza?
Absolute value of u. Natural log of absolute value of u plus c.
Okay, which is 1 plus e to the x plus c.
Yeah.
That's a fine job. Where's a bell? Hey, we got a bell there. Fine job. Got a half a bell. Hey, Eric, you know, speaking of the froze in the 70s, you know, there was a very famous actor on Chips called Eric Estrada.
We have an Eric Estrada in this class.
Do you really? Was he on Chips?
Yeah, he was.
Ever see that show?
Yeah.
You have?
Show Eric Estrada.
Eric Estrada? We have Eric Estrada? Hey, put Eric Estrada on the line. We're going to ask him a calculus problem.
All right, here it comes.
There he is, the man on Chips.
Hello?
There he is. Hey, Eric?
Hello?
Hey, Eric?
Yeah.
Do you ever see that show, Strips? Strips. Chips.
Chips, yeah.
The guy's name was Eric Estrada.
Yeah, I know.
Do you know, like, the women in the 70s really wanted him?
They did.
They did. I don't know. You know?
I wish it was the same here.
Hey, Eric, that's not what I heard. I heard that. Okay, you ready for a problem?
Yeah.
Okay. Let's.
I can't hear.
You can't hear?
Shoot. Yeah, I can
Okay,
hear.
let's give you. I don't know. What did you get on your last test?
Man, I don't remember. I haven't taken one in a while.
A, B, or C?
F?
Okay. Let's try this then. Okay, here you go. Okay, Eric Estrada, the man on the motorcycle.
Cosine? Hold up. I can't see it, man.
The sine and natural log of x.
Cosine?
So it's cosine.
1 over x.
Oh wait, the derivative of sine of u is what?
Cosine is a natural log?
It's the derivative of sine of u is what?
Cosine natural log of x
Okay, excellent.
times 1 over x.
Times 1 over x. Okay. And so that's going to be equals cosine natural log of x all over x. So how do we do f prime of e to the pi then?
Plug it in.
Plug it in, baby!
Yeah.
Okay, what is natural log of e to the pi?
Pi?
What's cosine of pi?
Whoa! -1?
Negative 1. Excellent. So the answer is -1 over e to the pi. All right. Eric!
Yeah.
Fine job, Eric! All right? Fine job. Make sure you call it again, okay?
Bye.
Bye.
Take care.
Hey, DeMarcus, what's going on?
Hey.
How's it going?
All right.
I got your picture. Hold on for a second here. Good. DeMarcus Ballard, ladies and gentlemen. There he is right there. It's a fine-looking picture there. Woo! Hey, how come there's no applause in the background there?
Say what?
DeMarcus?
Yeah. Oh yeah, I have a question.
Uh-oh. I don't do questions. No. What's that?
Just a while ago you picking on Skyline again.
I wasn't picking on Skyline.
That's the second week in a row.
No. I wanted to say that the reason why I'm showing you a picture that some girls at WTY do want to see you.
No excuses, just results.
What's that?
No excuses, just results.
That's Skyline's motto, right?
It used to be.
Hey, I like that. What'd you do in class today or yesterday?
Today we did area of a region between two curves.
Are you ready to try one of those problems?
Yes, sir.
Okay, here you go. Let R be the region enclosed by y equals e to the x, y equals x equals 2, and x equals 0. Find the area of R.
Oh, okay. Could you graph them
Okay, we graph them, right? So y equals x looks like that, and
I can't see. Oh, okay. There
y
we go.
equals e to the x looks like this. So we want this region right here. So what would you do?
Subtract.
Okay, what are we going to integrate from
Well,
what to
integrate
what?
first.
Okay, what are we going to integrate?
Integrate from 0 to 2. Ex dx minus the integral of 0 to 2 x.
That's excellent, DeMarcus. There's no stopping DeMarcus. You can only hope to contain him. Hey, and you can also, when the limits are the same, you can combine this, e to the x minus x. So it's e to the x. What's the integral of e to the x?
Let's forget this one.
Integral of e to the x is what?
X
It's e to the x. And what's the integral of x?
squared. Oh, over 2.
Right. And so you just take that from 0 to 2. And so what would the final answer be?
Okay. It's gonna take a while. Alright, you can plug in the 2 for the
Okay.
x. And then minus 2 squared over 2, which will be 2.
Okay.
E to the 0,
What's e to the 0?
1.
All right. And then minus 0. So the answer is just e squared minus 3, right?
Right.
DeMarcus.
Yeah.
Fine job, DeMarcus.
Finally got the
Fine job. Hey, tell you're Mr. Morrow, right?
Yes.
All right. Make sure I know he's treated you to a candy bar out there, right?
Kind of. A honey bun and a 7-Up.
Honey bun. I love honey buns, man. Honey bun 7-Up. That's a little too much sugar, though. Okay.
Yeah.
Hey, listen. Call in again. All right. Great job.
All right.
All right. Who's out there?
Hey, how's it going?
Epsilon.
Yes.
What school?
WT White.
The Longhorns.
Yes.
Okay. Here's a real hard problem. You ready?
You don't have my picture, but you could have called me on Channel 8. I was Student Athlete of the Week.
You were student athlete of the week.
Yeah.
What event? I mean, what
The track.
track?
Mm-hmm.
What'd you run?
The 200.
I think we talked about this
Yeah, we
last
talked
time.
about it.
That's right. We talked about this last time. Could you run like under 21 or something crazy
Yeah,
like
you're a
that?
long distance runner.
Yeah, I know. That's right. Well, a long time ago. Right now, I'd be lucky if I could jog that much. But hey, Epsilon, you ready for a tough problem?
Yes.
Okay. Here you go. Was that Miss Harmon making a
They're
snap
calling
sound?
you strips.
Tell Miss Harmon that I'll take that picture of the governor and put it somewhere. So put
You know
like
where you're
on a
looking at? She's
billboard or
right
something.
there, so it's like you're looking at her. All right.
Okay, what do we do?
Looks like a simple derivative.
So what do we do? All right, ready, equated for a line tangent. If we want to write equated tangent line, what two things do we need?
All right. You need to find the derivative.
Find the derivative. What's the derivative?
Point slope.
What's the derivative of that?
All right, x squared minus 4 times 2 minus 2x minus 5 times 2x
Excellent.
over divided by x squared minus 4 squared.
Okay, and so at 0, what do we got here? We got negative. We got 8 minus 0. So we got 8 over. It looks like 16 to me when you plug in 0. So the slope is 1/2.
Yes.
Okay. All right. If the slope is 1/2, how do we write the equation of the line, Epsilon?
All right. You have x is 0.
All right. When x is 0, what does y equal?
X is 0. 2. No, 5 over 4.
Right. It's negative 5 over negative 4. So you got the point 054, and the slope is 1/2. What do you got as the equation of the line?
Y minus 5 over 4 equals 1/2 x.
Excellent. That's an excellent job, Epsilon.
Thank
Student athlete of the week, ladies and gentlemen. Student athlete of the week.
Thank you, thank you, thank you.
Is this Shannon from Carta? Yeah, speaking of the 70s, there used to be a show called Welcome Back, Carta. You guys ever see that show? What did you just say? What did you say? What? Shannon, what was that?
How are you?
Fine, thank you for asking. How are you?
Okay. I need help on growth and decay.
I do too. So that's amazing that you said that. You have a test on that coming up?
Say it one more time.
Do you have a test on that coming up?
Yes, I do.
Okay, I'm going to make up a quick problem for you. Okay, you ready?
Go right ahead.
All right. How about the population at Kata in 1990 was 300. In 2000 was 500. What do you expect the population to be in 2010?
Don't know. The initial population is 300.
Right.
So it's 0, that's 300, and then what's the difference? That's like 2,000. So that's 10 years to 500.
Right. So what are we going to do?
I can't hear. Oh, it's 0 to 300, and that's 2,000. So it's 10 to 500.
Okay, so we know this is y equals c e to the kt, so we know c is 300, so y is 300 e to the kt, and we know that when t is 10, y is 500, right? So we got 500 equals 300 times e to the 10k. Now what do we do from there?
Divide both sides by 300.
Divide both sides by 300, excellent.
Then you get 5 over 3 and natural log both sides.
Okay, so you get 5 over 3 is equal to e to the 10k. Natural log both sides. Natural log of 5/3 is equal to 10k. So k is just equal natural log of 10/3. Natural log of 5/3 all divided by 10. Well, how do we find the answer then? What's the population in
We plug in K.
we plug in k. Okay, we plug in k into here. So we got y is equal 300 times e to the natural log of 5/3 over 10 times t. Well, what does t equal?
It's 20. From 2000 to 2000.
Right, it's 20. So 20 divided by 10 is 2. Okay, here's a little algebra now. This turned out to be a better problem than I thought. It's no calculator. E to the 2 natural log of 5/3. How can you do that without a calculator? How can you simplify that problem without a calculator?
The E and the natural log cancel.
Well, yeah, but first, before you do that, what is 2 natural log of 5/3 equal to?
Square root of 5/3.
Okay, so it's 25 over 9. Excellent. So it's 300 times e to the natural log of 25 over 9. And then now, e to the natural log of 25 over 9 equals what? What's e to the natural log of 25 over 9? Shannon?
25 over 9.
Right, so it's just 25 over 9. And you could simplify this. You could divide both things by 3, and you get 2,500 over 3. Hey, Shannon, that's a great job. There you go.
Yay!
Yay! Where's the bell? There's a clapper. Shannon, hello? Erica!
Hey, what's up?
Hey, what's going on? You want your picture?
Hey, I can't hear you.
Why not?
On the phone, I can't hear you. Okay, now I can.
You can?
Yeah.
Is Channel 4 out there?
Yes, like right in my face.
So they're in your, wait a minute, they're in your face, and so are you nervous?
A little.
So now, Erica, were you nice to me last time? I think.
Yes, I was.
Oh, you were, huh? Okay. Gonna make you Erica Bonilla. We're gonna have both shots, the glamour shot. And Erica Bonilla on TV! Okay, Erica. All right. Since Channel 4 is out there, we'll be somewhat nice. Okay, take a look at this graph right here.
All right. Zoom in a little.
Okay, if this is the graph of f prime. Okay, you got that? Want you can put that to memory.
Okay.
Okay, we can't do a split screen here. Which of these, if that's f prime, which of these is f?
F.
Okay, take your time. Well, I'll draw for you. I'll put it back. Okay, I'll put it back. Draw. Someone draw this on the board for Erica. Draw that graph on the board for Erica. That is f prime.
All right.
That is f prime, Erica. You ready?
Oh yeah, because it's e to the x.
Okay, if that's f prime, which of these is f?
It's still gonna be the same one. The number one.
Why? How could it be the same one? How could f prime and f be the same graph?
Because it's positive.
Because what's positive? Don't say it's.
Because the function is the derivative is positive. The first derivative is positive.
If the derivative is positive, Erica, what does that mean about the function?
That the function is increasing.
The function is always increasing, and number one is the only one that's like that. So that's excellent, Erica. Excellent. Now, hold on. We're not done with this problem. What does that graph look like? What does that graph look like? That derivative one.
Like, is that, the e, I already said it.
It looks like e to the x, right?
Yeah.
And so we know if f prime is equal to e to the x, then we know f is equal to what?
The same thing,
Yeah, it's e to the x plus c, right? That's an excellent job. Hey, put someone else on, okay? Put me. I think you're volunteering this. I only got hard problems.
Hey, Emily wants to talk.
Oh, Emily wants to talk? Okay, all right, Emily.
All right, here she goes. Bye, Greg.
Bye.
I want my dollar. Say you're gonna sit down.
No. I didn't make a mistake. Okay, Emily, you ready? There it is! Hi. Hey, Emily. Are you nervous?
No.
You're not?
Really. No.
Okay, I'm gonna give you here you go. We'll try this one then. F of x is equal to natural log cubed of x squared. Find f prime. What's f prime of x and what's f prime of e?
Can you rewrite it?
Sure. I'll make this. F of x is equal to natural log cubed of x squared. So what's f prime of x equal to? Well, how would we want to rewrite f of x here? How would we want to?
Natural log.
What?
Of x. X squared.
Natural log of x squared.
Oh, over that parentheses. And cube it. Yeah, and cube the
whole thing, right?
Yeah.
Not just the x squared, you got cube the whole thing. Okay.
Yeah.
If that's f of x, what would f prime of x then be?
Bring down the 3.
Bring it down, baby. Bring it down.
And then u prime over u.
And so it's you make that squared in time.
Squared.
And what's the derivative of what's inside?
The 2x over x squared.
Right, which simplifies to what? What's 2x? What does that simplify to?
2 over x.
2 over x, okay. So if that's the case, what would f prime of e be? Well, let's plug that in. So it's natural log of e squared, quantity squared times 2 over e. How can we simplify that?
Yeah, put the 3 on top of the e.
Put the 3 on top of the e?
It's going to be 6.
Okay, so make that 6 over e. How do we simplify this in here?
Oh, the natural log.
Yeah, what's natural log of e squared?
2. It's 2.
It's 2. So this is 2 squared, that's 4. 4 times 3 times 2 is this answer is 24 over e, right?
Yeah.
Erica! Emily!
Yeah.
Fine job out there. Fine job.
Thank you.
Hey, why don't you put one more person on there? Just only because, we got to get some good
Myra wants
footage
to do
here.
it. Myra wants to be on the phone. Hold on.
All right.
Hold on.
Who does? Hello?
It's Myra.
Myra?
Yeah, it's
Hold
me.
on. How you got your picture? Hold on, Myra.
They held a gun to my head. I didn't want to come up here.
Are you nervous?
Not really.
You're not? Because
No.
it's too easy for you?
No, but
Look at
I'll
that.
survive.
Look at that with the, it's the,
Hey, Greg, you're on TV.
I know. I'm
No,
fully aware of it. And thanks for calling me that. too.
on
I
the
appreciate it.
news.
Myra, that's it, Myra! Okay, here you go. Okay, Myra, here we go. You ready?
Mm-hmm.
Okay. Let's try this. This is a little harder one.
You have to separate the variables.
Okay, so how do I do that?
Multiply both sides by dt.
Okay, multiply both sides by dt. dy is equal 16 plus y times dt. All right?
And then divide both sides by 16 plus y.
Okay. Is equal to, all right, hey. Okay, now what do I do?
You integrate both sides.
Integrate both sides. What's the integral of dy over 16 plus y?
1 over 16 plus y.
1 integrate both sides. What's the integral of dy over 16 plus y?
The natural log of the absolute value of 16 plus y equals
What's the integral of 1 dt?
t plus c.
Excellent. Okay, now what can I do about that initial condition up there?
E both sides.
Well, before we e both sides, let's try to solve for c. You can do it that way, but it might be easier if we do it this way.
Plug into 0.
Okay, we plug in 0 and plug in 4 for y. We get the natural log of 20 is equal to c. So now we got natural log of 16 plus y is equal to t plus natural log of 20. Right?
Mm-hmm.
Okay, now I want to find y when t is natural log of 2. So I got the natural log of 16 plus y is equal to natural log of 2 plus natural log of 20. How can we simplify natural log of 2 plus natural log of 20?
Multiply.
So what is it equal to?
Natural log of 40.
Natural log of 16 plus y, excellent, is natural log of 40. So if that's the case, if natural log of 16 plus y is equal to natural log of 40, what does y equal?
No, it's 24. Yay!
Myra, that's a fine job, Myra.
Thank you.
Okay, make sure. Congratulations. Hey, great job. Call in again next week, okay?
All right.
Lacey Stevens.
Hi.
Hi, how are you?
Good. I've been on hold forever.
I know. Well, see, Channel 4 is out at Molina today. Filming.
Miss Arthur says she doesn't care.
I know she doesn't care. I know she doesn't. I'm sorry. But Lacey Stevens,
Yes.
you are, don't forget, Lacey Stevens. I need a picture of you.
Okay.
Some guys at Hillcrest some of Miss Arthur's Hillcrest students wanted to see pictures of you.
Oh, really?
Yeah, they did. I asked,
Okay, I'll send one in.
Okay. How do we do this?
Huh?
How do we do this problem?
Separate the variables.
Separate the variables, okay?
So dy equals dx times 4xy, and
Okay.
then you bring the y over, divide by y. So dy over y equals 4x dx.
Okay.
And what? Integrate both sides.
Okay, and you integrate dy over y. What do you get?
Natural log.
Natural log of y is equal to, what's the integral of 4x, Lacey Stevens?
4x squared over 2.
So it's just 2x squared plus c?
Yes.
Okay, now what do I do? Find y if when x equals 1, y equals 1. What do I do there?
So you use 1 comma 1 to find c.
So what's the natural log of 1 is equal to 2 plus c? What's natural log of 1 equal?
0.
So it's right. So what does c equal then?
0.
Well,
Negative 2.
right, c is equal to negative 2. So therefore, you have the natural log of y is equal to 2x squared minus 2. So what, if I have to solve for y, what's the final answer?
You have to, y equals e to the 2x squared minus 2.
Excellent. You e both sides, so y is equal to the e to the 2x squared minus 2. Fine job, Lacey Stevens!
Thank you.
No, thank you. All right. Who's out there?
It's Bill Massey again.
All right, Bill, you ready to be challenged?
Not exactly, but
Well,
we'll
you
go
are.
for it.
Here you go.
Okay. Hey, wait. As long as Channel 4 is out there, you mind putting my picture up?
Oh, I'm sorry. How rude of me here. I got the picture. I got just you know the picture here. Thank you very much. You guys, we're getting an aggressive crowd here. Hey, Bill Massey! Oh, wait, hold on. There's Bill Massey!
That's. Thank you.
How's that? Is that better?
Yeah.
Because our current girlfriend doesn't appreciate that, right?
Oh, not in the slightest. No.
Okay. Hey, Bill.
Yes.
This problem looks innocuous. You know what innocuous means?
No, I'm a math person.
It
not
means
much
harmless.
English.
It looks harmless, but it's tough. Let's see. This ain't an easy problem. And you have 3 minutes and 28 seconds.
Well, let's see. I'd want to dissociate the square root of x on the bottom. So you'd have square root of 1 over the square root of x plus x to the 3/2.
So you want to change it to, that's not bad thinking, but let's see if that's right. How does that, plus x at 3/2, that's what you said, does that help us out? Can we do that?
It probably doesn't help us out.
It doesn't help. That's
Okay.
excellent that you recognize that.
Okay. Oh, wait, so, let's see, it'd be just use substitution.
Just use substitution?
And so
All right.
if you-
What's u going to be?
Square root of x.
Okay, if u is equal square root of x, all right?
Mm-hmm. And so, let's see, if u squared would be x,
You cannot stop Bill Massey, ladies and gentlemen.
and so du would equal 1/2 times x to the negative 1/2 power.
Okay, so it's just 1 over 2
dx.
square root of x, okay?
Gotta have dx. And so then okay, so we have dx over 2 square roots of x, and okay, so to get dx over 2 square roots of x in the equation, you need to add a 2 to the denominator, and to do that you would have to multiply the denominator by 2, and to do that you'd have to multiply the entire thing by 2.
Okay, so I got 2 times,
2 times 1 over 2 square roots of x times 1 plus x.
okay, but how does that help us?
Because that gives you 2 times the integral of du over u.
du over what?
U.
du over what?
U?
du over what?
Gosh, I'm missing something.
du over 1 plus u squared,
Oh, yes, 1 plus u squared.
right? This is your du, 2 times du, 1 plus u squared. And what is this the integral of? What is this?
That's arctan.
What is it?
Arctan.
Arc what?
Arctan.
So it's 2 times the arctangent of just u, which is arctangent of square root of x. Fine job, Bill Massey!
Thank you very much.
Hey, you guys, make sure you call in again next week for another fine show of AP Calculus. 54 days left, and good luck. Study hard. Bye.